and welcome to this interview series ahead of Data Center World on the 22nd and 23rd of May at Messe Frankfurt. I'm Rebecca Uffendale, tech reporter at Techarati, and today my guest is Babak Falsafi, president at the Swiss Data Center Efficiency Association and professor of computer science at EPFL. Babak will appear at Data Center World later this month, but today we'll be talking about an innovation that have affected their lives. So thank you so much for joining me today. And so have you thought of an innovation that's had an effect or will have an effect on the future of your life or is currently in effect?
Yeah, absolutely. So at SDEA, we launched a couple of years ago. We have created a platform and a label to properly quantify the efficiency and emissions of data centers. So what's happening with data centers is that the silicon technologies that form the foundation of digital computing were getting denser for 50 years, according to what's known as the Moore's Law. And this 50 years is now, this exponential improvement has come to a slowdown. Eventually it will stop because all exponential eventually stop, for physics reasons, and we're reaching the physical limits of silicon density. And because of this now, if we want to have more computing, if we want to do AI, if we want to grow according to exponential demand, we have to build more. And what we're doing at SDEA is to give customers an opportunity to properly measure and publish an index that says, here is how well we're using this electricity that's going into the data center.
Wow. And so this must have been quite a while in the making. At what point did you feel that there was a need for this innovation? Or has it been something that's been an instant kind of recognition, or has it been a slow burn over a course of many years?
Absolutely. That's a great question. What has been happening in the past 20 years is that there is a metric that is widely used in industry. It's called PUE. It basically captures the amount of electricity we feed into the building that houses the computing equipment. And this PUEs now, because of advancements, improvements in technology, they're reaching really efficient levels, to the point that a small fraction of overall electricity is going into all the infrastructure that houses computing equipment, including cooling, including electrical subsystems, anything that goes into the building. And pretty much the majority of electricity is now going into the computing equipment. And there is no industry standard for measuring how well we're using that electricity. And that's why we're happy to help, is that we've now also released an index and a label and a platform where it can help you measure this index for the IT customers to figure out how well they're using the electricity in your IT equipment.
It seems like you have a real interest in fostering a sense of community and a collaboration in order to kind of reach a common standard or a common goal. Has this always been a theme throughout your life?
It's a very good question. I'm an academic and we're also a nonprofit. So SDEA, the Swiss Data Center Efficiency Association, is a consortium of academic, industrial, and other nonprofits. And absolutely, I'm a founder of a research center at EPFL called EcoCloud. We started looking at technologies for sustainability with data centers already 14 years ago, and this research center still goes on.
And how far has sustainability come throughout the industry? I know there's been a big focus on it at the moment.
There's great interest now. I think it's also partially driven by governments. They're really interested in finding out and assessing and perhaps inspiring stakeholders to also report. What we found in the Swiss market is that in recent years there's of great interest, but these sort of stakeholders who build and host computing equipment, they're reaching really high standards of sustainability in the electricity consumption operation. Their IT customers, however, not so much. And I think that's where we'll see a lot of improvement in the coming years.
Can you talk a little about your history as a computer science professor?
So I've spent most of my life either in computer science, which is technologies that underlie computing, or electrical engineering. These are two fields that are close to each other. My immediate area of research is right in the middle, which is designing hardware. My research interests are designing servers and specifically related to this, to the fact that we no longer are getting exponential improvements in density from silicon, which is the foundational technology behind all digital computing. So how do we find ways in which we can improve the design of both software and hardware to allow further scalability of computing within the same resources we get from silicon?
Looking forward a little bit, what developments or trends have you got your eye on currently?
And I'll talk about this also during my talk at DCW. If you look at recent trends in power consumption, electricity consumption of the latest chips that are coming out of vendors that will end up in data centers, there are really two key technologies that we use in data centers. One is called the CPU. These are chips that are manufactured, designed, and built by Intel, AMD, and many other vendors. These provide the foundational computing in data centers. And then there are just specific chips that are primarily targeted for AI, and the leading vendor of these chips is NVIDIA. If you look at the power consumption of the latest chips, because this Moore's law, this exponential phenomenon, which lasted for 50 years, has now basically reached its limits of physics, you will see a exponential increase in power consumption of the AI chips that are coming out every generation. And also not as steep of an exponential, but a phenomenal increase in power consumption in CPUs, which is the foundational chip for all of computing in data centers. And so these trends basically mean that when you have a rack of servers, your rack typically would have maybe 20 housing units in it to house the servers. Today's racks, if they basically offer and consume about 8 to 10 kilowatts of electricity. In the near future, these racks with AI, they have to house maybe 80 kilowatts, 120 kilowatts. So this power consumption and electricity density of each rack is going up. And this means a phenomenal impact on the industry, because we were now going to need technology to deliver this electricity. We need to find ways in which we can cool these racks, at maybe an order of magnitude more power dissipation than we're doing today. And of course, we also need to figure out how to use this electricity we're delivering to the servers in a sustainable way, so that we maximize the output of the data center. And those are all super interesting technologies to be working on.
Do you think there needs to be more of a distribution between the fear and the opportunity of AI?
We don't know that yet. This is a topic I discuss with colleagues around the world. I've been on recent panels. It comes up almost every month, and it's a really good question, and it's too early to say. What appears to be the case is that we will be able to manage the amount of electricity consumed by AI for most of the emerging AI applications. Eventually, in the near term, we will have a projection as to how much we need, and we will also know then what the benefits of that would be, because the growth in AI also causes an instability in a way we can project at what point this growth would eventually level. And we're seeing that. We're seeing emerging applications that are pretty happy with the size of AI models they've already trained. And so I think the jury is still out, but I'm optimistic on this topic.
I mean, there's a lot of speculation within the industry, and I think a lot of intrigue and curiosity. And as someone who's been in the industry for so long, and as someone who is a professor, what advice do you have for young researchers or young people entering into the industry?
These are changing times, and like I said, there's so many different technologies that could all come together to help us move or create the future of data center. So this is not just computing. I mean, as you said yourself, we're talking about electrical engineering, we're talking about mechanical engineering. cooling technologies have not advanced as fast because it's not just a question of what is the best technology, it's also a question of how cost effectively can we bring it to the market, right? So the cooling technologies we use today in data centers, typically within the racks, are air cooled. This is not the most efficient way of cooling, but it's the most cost-effective way of cooling. And because of the power consumption demands are going up from the chips themselves, we have to go to liquid cooling. So there's a phenomenal spectrum of technologies that young people can get into. We need to look at, material life cycle assessment for sustainability of material we use in data centers. So there's so many aspects of it. And of course, on the computing side, AI is moving fast, and we don't really know why we're getting results from AI. We just know that by tweaking something empirically, we can get better results. So the way we do research in AI is fundamentally different from conventional research, where we reason about something and move forward. And this is not the most sustainable way of computing, of course. So there's potentially a lot of waste in there, but because it gives us results and there's a return on investment in that result, we move forward with it. But at some point, this will level and we'll have a much more rigorous and methodical way of advancing technology. And so I think the future is bright for young, curious minds to get into this. We also need to invest in AI technologies to retrain people, because AI is also going to get rid of a lot of jobs.
Yeah. And it seems like you have a lot of passion about this topic in itself. Is there anything that you hope to find the answer to in the near future, or anything that you're guiding your own research aside from this innovation you've developed?
For us, AI and SDEA, AI is not a difficult challenge, because efficiency assessment of typical software stacks that are used in data center. Software stacks can be quite deep, with many layers of software working together, running on these CPUs. It's more of a complex environment to assess efficiency and exactly figure out where electricity is going. Fortunately, we have sort of moved forward one step in that direction, have created a platform where customers can come in and get an index out of it. But on the AI side, things are easier, because we know that AI workloads do mostly simple arithmetic operations and mostly regular use of both software and hardware, which can be assessed in terms of efficiency much easier than a typical software stack that runs in data center. So in that sense, from the SDA side, I think would challenge is a simple opportunity for us. But in general, where do I think we can help moving forward? We're looking at all sorts of interesting ways in which we can use the electricity that's coming into your typical server equipment today in a much more efficient way, by just changing the way we organize the design of the hardware and the software together, so that we can then identify popular workloads that are emerging to support them a lot more efficiently and use less electricity for a given output.
What is it that you'd hope the attendees will learn at your anticipated session at Tech Show Frankfurt with Data Center World?
Well, I'm going to introduce, first of all, our platform to the customers. We're going to make the case for what's going on with the future of chips that are arriving. What does it mean for data center stakeholders? The Data Center World is a fantastic environment to meet everyone, because it's a really large event. And then talk to them about our platform. We have 3 calculators that we've launched. The calculators are available whether you want to get certified or not. And what the calculators do is that it was a calculator for your energy flow inside the data center. From the time electricity arrives until all energy is used, our calculators take into account heat recycling, which is a hot topic for data center constructors today. They take into account on-premise renewables. So we also take advantage of sustainability through renewable energy. And then second calculator, which is more important perhaps than the first one, is that we have a calculator for IT efficiency. That means your server equipment, your compute, your storage, your network, technology excellence, available or allowed operating temperature. So we look at technology excellence. We reward a number of KPIs that then quantify into this index that the customer can use to say, okay, this is how our efficiencies are. And we've found also through market research that IT customers are the ones that really need this. They're using a lot of electricity, they're buying a lot of electricity, they're not using it. And then the third calculator is an emissions calculator for the source of electricity. So we have, of course, government published data for source of electricity in Switzerland, but in other countries, we're together partnering with a company, with an organization that provides a web service that gives you online emissions for electrical grids where this information is available.